welcome back to MAT 1033 Intermediate Algebra. My name is Sean Perry. This is video number 19. We're going to be talking today about graphing inequalities. So let's begin with an example of an inequality. X is positive, all right? So first we need to translate this into an inequality. Think about how that might look. So the positive numbers are all those numbers greater than 0. So we can use a greater than symbol in this way. We could have also said that 0 is less than x. That would have been equivalent. To graph something on a number line, we shade wherever that statement is true. For equalities, these look like points. But for inequalities, there are many numbers that would satisfy the statement x is greater than 0. And we're going to want to shade all of them. So we draw a number line. I usually put as few tick marks as I have to. In this case, we're just talking about something being greater than 0. I'll put a tick mark at 0. And then we will shade those numbers to the right of 0. These are the numbers that are greater than 0, and any of those, when inserted for x, would make this statement x is greater than 0 a true statement. Now we use this open circle here to indicate that we are not including 0. 0 is not greater than 0. And so we exclude 0 from our shading. But because it's so hard to see that you're excluding a single point, we use this big open circle to indicate that 0 is not a part of this interval. It's not a part of this set of numbers. We're not including it in our graph. Some books will use an alternative notation. They'll use a parenthesis for their non-inclusion of a number in a shaded interval. And this is kind of nice because it corresponds well with interval notation. So with interval notation, you want to put a start and a stop number separated by a comma. And then we use either brackets or parentheses to indicate whether we're including or excluding that number. In this case, we're going to start at 0, and we're not going to include it. So we're going to use a parentheses. Then we're going to go all the way up to, well, we don't ever actually stop. There's no largest number greater than 0. And so what we do is we put an infinity symbol in this place. This is an upper bound on the numbers. It's not a number itself, but it indicates that it's greater than any real number. And because it's not a number itself, when we use infinities in an interval, it's customary to use parentheses to show that we're not including that. It's not a valid number, and so we wouldn't include it when we're talking about the set of numbers greater than 0. So finally, there's set notation. This is sort of a version of set notation. We use brackets to indicate a collection of numbers. We say what the name of the number is, and sometimes there's a little bit of extra notation here to say where x comes from. If I don't use any extra notation here, I just want it to be implied that x is going to be a regular old real number from the number line. Then there's a symbol that means such that. There's two common symbols, and a vertical line is one of them, which means such that. And then there'll be a condition here. So this will say all the x's such that x is greater than 0. That's also what's meant by this interval here. Now, intervals, which look like something comma something in parentheses, are very easy to confuse with a coordinate. We talked about coordinates x comma y just in the last section, and this happens a lot in mathematics. And this happens a lot in mathematics. This is called notation abuse. You might feel a little frustrated at that, but notation abuse is a lot like homonyms in language. There are many words in the English language, for example, that are spelled or pronounced the same way, and they mean different things, and you have to use context to sort out what those are. For example, there's bat and there's bat. There's a bank and there's a bank. There's a bank you keep your money in, and there's a river bank. And in the same way, you need to use context to figure out if I mean the coordinate AB or if I mean the interval AB. So let's talk more about intervals that look like this. The expression x is greater than a is less than b, right? Or a is less than x is less than b. This is a compound inequality. And what it means is that both a is less than x and x is less than b. When we say and in mathematics, we mean both of these statements must be true. This contrasts with or statements where either one could be true. So here's the graph of the expression a is less than x, which is less than b. Here is its interval, which looks just like these with parentheses. Parentheses used to show we are not including A and B. And here's the set. So a colon is another symbol that also means such that. So we would read this as the collection of all x's such that A is less than X is less than B. Let's look at one more example. Let's say X is less than or equal to 2. Here's the graph of that. Notice that we fill in the circle to show that we are including 2. So a closed circle shows that 2 is part of this. In the same way that plugging into here, we'd have 2 is less than or equal to 2. That's a true statement because the or equal to part is fine. Now you hear or right in there, less than or equal to. Or in mathematics, meaning if either one is satisfied, then the whole expression is satisfied. Some books will use brackets in place of those closed circles. And this sort of heralds interval notation's use of the less than or equal to's here. It's going to use a bracket to indicate its highest point in this case. The negative infinity part here is just the other end of the number line. It's a lower bound to all numbers. And in set notation, we might say the set or the collection of all x's such that x is greater than or equal to 2. So set notation gives us symbols that can talk about and or conditions, and they can talk about questions about whether intervals overlap or ways of sticking intervals together to make bigger things. And these are going to be pretty useful operations for us to know. So I'm going to mention them briefly here. But if you would like more information, I believe I have some videos up, or I will soon, about set notation, and you can check it out there. So here I've shaded sort of a multiple regions on this. I've shaded one up here and one down here. How might I say the whole thing together? Well, that's what we use this big U symbol for. This symbol is called cup, and it stands for union. The union symbol combines these together so that we're talking about one set of numbers that has a component here and a component here. In set notation, we might use the or symbol to knit these together. We might say the set of all x's such that x is between a and b or equal to a and b, or x is greater than c. So this union symbol and this or here should not be thought of as distinct from each other. They are, in fact, related to each other. We use or conditions to say that if I'm either greater than c, or if I happen to be between A and B, then I should be considered as part of this yellow set. Let's look at another example. So here I've shaded two sets. I have a blue one, x is greater than A, and a red one, x is less than B. How do I talk about this combination of things in between there? Well, this is going to be related to the and condition, right? Where I have x is both greater than A and less than B. It has to satisfy both conditions. Here is a symbol for that. The symbol is called cap, like your ball cap, and the operation is called intersection. So we would say the intersection of these two intervals that are in red and blue is this purple intersection, is this purple interval between them. That's where both conditions are satisfied. In set notation, we would say the set of all x's such that x is greater than A and x is less than B. The and condition goes along with intersection, and it means that both of these conditions have to be true at the same time. The or condition, either one could be true either together or separately. But the and condition says, no, both of them have to be true at the same time in order for me to shade. Okay, here's some critical notes coming up. I want you to copy this. They are just the examples that we went over today in a little bit of a synopsis. Think of this as a TLDR. And I want you to copy this. You don't need to shade in separate colors, but if you're going to use the same color, make it nice and dark so I can see what side you shaded on. I want you to also try each of these as praxis exercises. So I want you to graph each of these inequalities. Pause the video at this time and give it a shot. Okay, let's see how you did. So the first one, x is less than 6. Make a marker at 6. It's strict inequality, so we leave it open. X is less than 6. It's on the less than side, so I shade everything to the left of 6. Okay, here's 13. Let's make a marker at 13. This one here says x is greater than or equal to 13, or 13 is less than or equal to x, whichever you prefer to say. They're the same. It's or equal to, so I'll shade 13 as a closed circle, and x is greater than that, so we indicate that by shading on the right-hand side of 13. Here I have two numbers. The compound inequality means both these must be true. It's an and condition. So just to be clear, this says that 2 is less than x and x is less than or equal to 6. Those both have to be true. So let's shade those. Let's put markers for my smaller and bigger number. That's 2 and 6 respectively. And we notice that it's strict inequality on the 2 and inclusive inequality on the 6. So 6 is going to get a closed circle and the 2 will get an open circle. So now I have two inequalities with an or condition between them. Remember, or means I'm going to shade if either one of them is true. They don't have to be true together. So let's say here's my 2 again, and here's my 6 again. And one says x is less than or equal to 2, or 2 is greater than or equal to x. So that would be this region here. It's got an or equal to, so we fill it in. And it's less than, so we hit it on this side. That's one way that this statement could be true. Another way is for x to be greater than 6. So we leave that open. It's strict inequality. It's greater than, we shade on the right-hand side. And this split graph here, these two components are where we would shade to make either one of these statements true. And so the whole statement, 2 is greater than or equal to x, or x is greater than 6, is going to be true in any one of these orange regions. So here I have two numbers to worry about, -1 and 0. Let's mark them. And this one says that x is less than 0 and it's greater than -1. We really have to think with and conditions about if that's even possible. But yeah, there are some numbers that are less than 0 but greater than -1. It's in fact all the numbers between them would satisfy that condition. I'm bigger than -1, but I'm also less than 0 here. And these are both strict inequalities, so we don't include them. Now, what about this last one? This last one I wanted to be a little bit more challenging. I have -1 and 0 as my critical players here still, but let's read. It says x is less than 0 or x is greater than -1. That means that as long as one of them is satisfied, we're good. Where is x less than 0? Well, that's all of these guys all the way down here. And what about where is x greater than -1? Well, that's all these guys up here. And I've tried to intentionally cover up those circles there because really what I've done is shaded the whole number line. You can't find a number on the number line such that at least one of these isn't true. And so for this graph, we would shade the entire number line. Let's really quickly run through these and remark on their interval notation. So if you want, you can pause the video again right here, and I'm going to put their interval notation on the side. This one is -infinity up to 6, not inclusive. This one is 13 up to infinity, and we use a bracket on the 13. This one goes from 2 without including it up to 6 and then includes it. So we use parentheses and bracket respectively. This one can't be written as a single interval because it's actually two components. So we're going to need to write one component and then union it with the other component. This one here is one component. We can write it like this. How do I say the entire number line? Well, it's all the numbers between -infinity and +infinity. All right, that's it for this video. Thank you for your patience. Good luck with your studies. Have a great day, and I'll see you in the next video.